directory and run it directly from within the database without having to use a Java stored procedure, without having to use the scheduler built-in package, without having to do anything fancy. This works with external tables. External tables, the 9i feature, allowed us to query a file that existed in the file system outside the database as if it were a database table. 11G extends that and allows us to not only select from files in the file system, but also to select from a program that's run in the operating system. We can take any program that writes the standard out and query it as though it were a file itself. A select statement is going to run a program. The program generates output. That becomes our table data. This was created to make loading of compressed data easier. Somebody gives you a very large compressed file. Maybe they use gzip to compress it down. It's much smaller than it would be if it was uncompressed. Your job is to load that into the database. Well, in older releases, the first step would be uncompress the file, make it large. Then you can start to load it. Now, I can uncompress it and load it in one step. I don't have to create the uncompressed version of the file in the file system. I can load the compressed data directly. Here's how I would accomplish this. I'm going to have a directory where my files are. I'm going to have a directory where a program that knows how to uncompress these files is. When I create my external table, organization external, on this line 17, I'm going to specify the program that knows how to uncompress the data. So I want to load this file, emp.dat.gz. This is gzipped compressed data. I need to run this program against this file in order to achieve this load. Looking a little further, I can see that the file is compressed data. Here's my program, run gunzip. If I look at that, all it does is run the gunzip program, writes the standard output, writes on the screen the uncompressed data, and then $* just represents the file name that was passed in. In this case, it will always be emp.dat.gz. When I select from this external table, it automatically ran my script, uncompressed the data to standard out, and loaded it. So if that uncompressed file would have needed 500 gigabytes of space in my file system, I don't have to have 500 gigabytes of space anymore. I just write it directly to the database, and the database will write it directly into the data files. Anytime they give me a neat feature like this, I try to find a way to use it in a manner that the developers didn't anticipate me using it. I look at this and say, what else can I do with this? Something I've wanted to do for a really long time is to get a directory listing. PL SQL will allow me to read files. It will allow me to write files. It allows me to erase files. It allows me to rename files. It doesn't give me any ability to ask what files exist in a directory. It's sort of a missing piece of functionality. Using this capability, I now have a way to list files in a directory. I'm going to create a table. I'll call it ls after the Unix list files command. It just has one column, line. It's going to be one row of output. It's an external table, but it's going to run this script. The script is going to run ls, the command to list files in the directory. When I select star from the ls table, it will run my shell script. My shell script will cd to the directory that I want to list the files in. It will print those to standard out. They now become rows in a database table. I can do this with ls. I can do this with ps, process status. I can do this with VM stack, IO stack, any Unix command, for example, that produces output on standard out. Windows has various commands that produce things on standard out. You can write your own programs in C or Visual Basic that write the standard out. We can now query them directly as though they're a table. So this has a lot of potential. Another new capability is a feature called recursive subquery factoring. It's a really fancy name for a replacement for connect by. It can do a lot more than connect by, but it encompasses all of the functionality of the connect by statement in SQL. So it is an ANSI SQL syntax. We're not the only database that has it now. SQL Server has it. DB2 has it. So other implementations follow this particular standard. It can be easier for people new to SQL to understand than the old connect by syntax. But for many of us in the room, if you've been using connect by for 5 years, 10 years, or in my case, 22 years, the syntax can be a little bit confusing at first. But it can do everything connect by can do, plus a little bit more. Here's how it works. Our goal is going to be to print out the employee hierarchy. We would normally use a connect by statement to accomplish this. Instead, we're going to use this new ANSI SQL syntax. So what we're going to do is start with the with clause instead of select. This allows us to create a set of data that we can later select from down here in the actual select statement. So we'll call this emp data. This recursive query will always have two pieces. There will be a union all in between them. The first part of this query is sort of like the start with component of the connect by query. This identifies the first set of rows in our hierarchy, the things at the very top level. And here we're finding everybody whose manager is null. In the emp table, we all know that's the king record. So the employee whose last name is King, that will find that one record. Once we find that one record, we're going to feed that record into the second part of the query. Here's where the recursive part comes in. Notice how this is named emp data inside of the with subquery that's also named emp data. The recursion is taking place. We're building on the same result set. So we take that first record, we feed it into the second query, we join it to the employee table, and we find all of the employee records who work for King. So the first time we execute the union all statement, we find everybody who works for the person that was identified with the red query. We then take all of those records and we feed those into this subquery again. So the second time we run that subquery, we find everybody who works for anybody who works for King. We find the third level in the hierarchy. And we keep doing that over and over until we run out of data. We find no more results. This query will then produce this output. So the first record it would find would have been the King record. Then it would have taken the King record and found Blake, Clark, and Jones. Once it found those three, it would find everybody at this level. Once it found them,